Hello children, myself Malika and I teach chemistry. In today's video, I'm going to take class 11 chemistry, structure of atom. An atom is the smallest particle of matter. Atom can be divided into still smaller particles, electrons, protons and neutrons. These are known as subatomic particles. Who discovered these subatomic particles and how? What are the properties of these subatomic particles? This is what we are going to see in today's class. So let's start. Okay, we'll start with the discovery of electron. Electron was discovered by J.J. Thomson by performing discharge tube experiment. He took a glass tube filled with some gas. The pressure of the gas was kept at very low value. It had two plates, cathode and anode. Anode had a hole in it. Both the electrodes were connected to high voltage battery. One end of the discharge tube was coated with fluorescent material like ZnS, zinc sulfide. Any charged particle when hit the fluorescent screen produces glow. So now let's see what happens when current is passed through the discharge tube. When current is passed through the discharge tube, some invisible rays, particles, they will start coming from the cathode and they pass through the hole in the anode and they strike the fluorescent screen producing glow. Okay, now when electric field is applied across the discharge tube, these negatively charged particles, they are deflected towards the positive plate, confirming that cathode rays consist of negatively charged particles known as electrons. On applying magnetic field across the discharge tube, cathode rays, they show deflection according to the direction of the external magnetic field. In 1897, J.J. Thomson performed one experiment to calculate charge to mass ratio of electron. He applied electric field and magnetic field in such a way that electric field deflection and magnetic field deflection were same. He then calculated E by M ratio by using the formula E theta E upon B square L, where E is the electric field, B is the magnetic field, theta is the electric field deflection, L is the length of the cathode ray. Charge to mass ratio came out to be minus 1.76 into 10 raised to 8 coulomb per gram. Next we will study about the properties of the cathode rays. Cathode rays, children, are produced from cathode when electric current is passed through the discharge tube. They travel in straight line. They are deflected by electric and magnetic field. The properties of cathode rays do not depend on the gas in the discharge tube and nature of the material of the cathode. You take any gas inside the discharge tube, any cathode made up of any material, the properties of the cathode rays are not going to change. Okay, cathode rays are deflected in the presence of an electric field. Cathode rays are deflected in presence of a magnetic field. Okay, we know this. Now next is the canal rays. Canal rays or anode rays. Anode rays are rays which are made up of positively charged particles known as protons. Let's see how anode rays or canal rays were discovered. Okay, canal rays or anode rays discovered by Goldstein. He performed discharge tube experiment. He took a perforated cathode. Perforated cathode means having holes in the cathode. Cathode and anode connected to battery. One end of the discharge tube coated with fluorescent material. When electric current is passed through the discharge tube, some rays start coming from cathode and some rays start coming from anode. Okay, their direction is opposite. Some rays coming from the anode, they pass through the perforations in the cathode and they hit the fluorescent screen producing glow. And these are known as anode rays because they came out from the anode electrode. They're also known as canal rays because these rays they passed through the perforations, holes in the cathode. Okay, now therefore also known as canal rays, and they consist of positively charged particles known as protons. Next is the properties of anode rays. Anode rays travel in straight line. They are deflected by electric and magnetic field. They can ionize gases. They can cause fluorescent screen to glow. Properties of anode rays depend on the gas and nature of the electrode. Okay, it depends. Properties of anode ray depend on the nature of the electrode and on the type of gas used inside the discharge tube. Next is the discovery of neutron. Neutron, you know, children, is a neutral particle present inside the nucleus, and it was discovered by James Chadwick in year 1932. He performed an experiment where he bombarded alpha particles. Alpha particles are doubly charged helium ions, okay, on a beryllium plate, and he observed that some neutral particles are coming out from the beryllium plate, and these neutrons, when passed through paraffin wax, okay, it was observed some protons are coming out. This showed that these neutron particles are not lightweight particles. They have some mass, and therefore when they hit the atoms, protons are removed from the atoms. Protons are, because they have some mass, to remove the proton from the atoms. So therefore it was proved that besides electrons and protons, some neutral particles are also present inside the atom, and they have mass comparable to the mass of proton. Now you can see this chart. Proton, relative mass 1, relative charge plus 1, charge plus 1.6 into 10 raised to minus 19, mass 1.67 into 10 raised to minus 27 kg. Neutron, relative mass 1, neutral charge, no charge, mass 1.67 into 10 raised to minus 27. Electrons, relative mass 0.0005, relative charge minus 1, charge minus 1.6 into 10 raised to minus 19, mass 9.11 into 10 raised to minus 31 kgs. So this finishes our topic, discovery of subatomic particles. Okay, so in the next video I'll be taking atomic models, different atomic models, Thomson's model, Rutherford's model, Bohr's model, okay, and finally the quantum model. Okay, till then, bye children.